Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. My name is Muhammad Zulsham bin Zulfadli. I'm from DPM 3. Before I starting, I want to give an introduction about hypothesis testing. Hypothesis testing is a statistical method to make a decision about a population based on sample data. It have a determine whether an assumption hypothesis should be accepted or rejected. This objective to make decision based on data evidence, to tell if observed differences are real or just by chance, to reduce decision making error type 1 and type 2 error. This application is for example medicine and healthcare, quality control and manufacturing, education and learning, environment science, marketing and advertising. This limitation cannot prove absolutely true. Result depend on the sample, risk of error type 1 and type 2, require specific assumption. Hypothesis testing have 4 types. First, that test, t-test, chi-square, ANOVA. These have 5 steps. First, set up HO and H1. Second, select suitable statistical test. Third, choose level of significance. Compare the test and summarize the result. Okay, now I want to explain how I get this answer for question number 2, set 1. When in this study, we are trying to find that out through statistics to see if the two different sprint training methods lead to different results. We have two groups, Group A and Group B, with 20 athletes. Group A training using method 1 and Group B use method 2. After 4 weeks of training, we measure the sprint time. Group A had an average time 12.3 seconds and Group B have a 12.1 second. It look like a small difference, but this question is it a statistical significant? To test this, we use the dependent two sample t-test. Why? Because we are comparing two separate groups. We don't know the population standard deviation, only the sample ones, and the sample size is a moderate. Our null hypothesis H1 said there is no difference. Both training methods are equally effective. Our alternative hypothesis H1 say there is a difference. One method might be more effective than the other. Since we don't know specific which method should be better, we use a two-tailed test with a significance level of 0.01 and the degree of freedom 38. The critical t-value is approximately plus minus 2.712. From our calculation, we got a statistic of 1.397, and since this value does not fall in the critical region, we fail to reject the null hypothesis, except yes. In conclusion, we don't have enough evidence to say that these two training methods lead to the significantly different sprint times. Studies like this are important because they help coach make a data-driven decisions, not just a really on guesswork. That's it all from me. Now, let's to see Man. Thank you.
Thank you, Syam. Hi, everyone. Today, we explore hypothesis testing and confidence interval tool that help us make better decision using data. Example, comparing student exam before and after a new study method. The problem statement, we are comparing the average grade between two class. This hypothesis set up new hypothesis. Now, I'm sure the calculation show the working clearly.
The given data, class A and class B, find number of student, mean grade and standard deviation for the answer. Now, I'm show calculation step 1 to step 5.
This example for graph. Next, conclusion. There is no significant difference between the average grade of class A and class B. Thank you for watching. Next, I will pass to Ani.
Okay, thank you, man. Hello, Assalamualaikum and good morning, everyone. Today I want to present a hypothesis testing about caffeine content in two types of coffee bean. The first, the hypothesis is the null hypothesis. Say there is no difference between a type A and type B. The alternative hypothesis say there is a difference. Okay, next, for the data, type A has a mean of 150 mg and type B has a mean of 160 mg. We know the population standard deviation, so we use a Z test. Calculate a Z test, and after that we get a value is negative 4.39, and the critical value are plus or minus 1.96. Okay, since negative 4.3 fall outside the critical range, we reject H-null hypothesis. Finally, the conclusion, there is a significant difference in caffeine content between two caffeine types. Thank you. And then I want to pass to the Shahrul.
Thank you, Anik. So today I will be presenting analyzing where we aim to determine whether there is a significant difference in participant weight before and after undergoing a weight loss intervention program. We collect data from 7 participants, measuring their weight before and after the program. To certification test is a program where effective we use the sample to test because we are comparing two related sets in measurements. The same participant measured at two different times. We set our significance level at 0.05. First, we calculate the difference between each participant weight before and after the program by the subtraction the after weight from the before weight. We then compute the sample means of the differences, which comes out approximately 6.4 pounds. Next, we calculate the sample standard deviation of the differences, which is around 3.5 to 3.532 pounds. The hypothesis population means difference under the null hypothesis is 0, assuming that the programs have no effect. And then we calculate the T static under the formula, which is T equals the divide standard deviation of the values T for the answer. T test answer 6.4 divided 3.532 divide 7 number to 7 equals 4.598. With 6 degrees of freedom, the critical value for the two tests at 0.05 is approximately 2.447. Since the calculated T statistic is 4.598 is greater than the critical T value 2.447, we reject the null hypothesis. Thus, we conclude that there is significant evidence to suggest the participant weight changed after the weight loss the intervention program. This support effectiveness of the intervention.